This question is from GATE 2013, Mechanical Engineering paper, question number 6. A link OB is rotating with a constant angular velocity of 2 radians per second in counterclockwise direction, and a block is sliding radially outward on it with a uniform velocity of 0.75 meter per second with respect to the rod, as shown in this figure. If OA is equal to 1 meter, the magnitude of absolute acceleration of the block at location capital A in meter per second square is. So it is given that the rod is rotating with angular velocity of 2 radian per second. Block is moving outward with a velocity of 0.75 meter per second. So we can write small v, that is translational velocity of this block is 0.75 meter per second. This length from point O, the pivot point, to A, which is the position of the block, is OA, which is 1 meter. And we need to find out the absolute acceleration for this block. So absolute acceleration A can be given as a resultant of the two component of acceleration that is experienced by block A. So because it is moving outward, it will experience Coriolis acceleration. So we have the first component, Coriolis acceleration AC square, plus the second component that the block acceleration will have will be the radial acceleration, because it is undergoing this combination of two motions, angular motion along with a radially outward motion. So now we need to find out the Coriolis acceleration and the radial acceleration individually. Coriolis acceleration AC will be given as 2v omega. For this derivation, you can refer to the reference given at the end of this video. This is a standard formula for Coriolis acceleration. You will have to remember this. Let's find out AC now. So AC will be equal to 2 into velocity is 0.75 meter per second, and angular velocity of the rod on which the block is mounted is 2 radian per second. So Coriolis acceleration turns out to be 3 meter per second square. Now radial acceleration for this block can be calculated by omega into its tangential velocity Vt. This is not same as the outward radial velocity. This has to be derived from again omega. So we can write omega into Vt as r omega, where r is the radius of circular motion. So this radius is nothing but from the pivot point center O to the location of the block, that is A. So this radius is nothing but OA, so we can write this as R, and omega is already given to us. So you can calculate AR as R, that is 1 meter, into omega square, which is 2 square. So this will be 4 meter per second square. We have both the individual values. Now we can calculate the resultant. So absolute acceleration of the block small a will be equal to root over 3 square plus 4 square. 3 square is 9. 9 plus 4 square is 16, which is 25. So A is root 25, which is 5 meter per second square. Let's go back and mark the correct option. Magnitude of absolute acceleration of block at location A is option C, 5 meter per second square. To learn more about the kinematics of velocity and acceleration, you can refer to the NPTEL video Dynamics IITM 5.6 Kinematics, Velocity and Acceleration from the course lecture series on Mechanics of Solids. This course is by Professor M.S. Sivakumar. He is from Department of Applied Mechanics, IIT Madras. I hope the solution will help you clear your doubt. Thank you.